Good morning, class, and welcome to this lesson on Electrostatics 1, Basic Electricity. Today, we will be able to define charge, the law of conservation of charge, and conductors and insulators. This lesson is going to be pretty basic. It's going to be just an introduction to this concept of what electricity is, and it's going to get us ready for stuff later on. Most of you probably will have learned this material back in middle school. So, let's look at electric charge. Electric charge. Electric charge is an intrinsic property. It's an intrinsic property. It is just a property of matter. Just like you look at a person and a person has a height and a weight. Those are properties of matter. We have height and weight. So like things like we have mass. Okay, well certain atoms have electric charge, and there are two charges that we have been able to define so far, and those two charges are positive and negative. Okay. Now, um, we've always defined in other classes typically that there's a positive one, negative one, but in physics we're actually going to break that down a little bit further. And if we're looking at an atom, and if we're looking at a specific electron, we're going to say an electron has a charge of E equals 1.60 times 10 to the negative 19th coulombs. Okay, Coulomb stands for Coulomb. It was the name of the scientist who discovered this. Okay, so this is the magnitude of the charge on an electron, or a proton. Okay, the only difference between this and a proton was to be negative or positive. Okay, but this is the magnitude of the charge, for either a proton or an electron. Okay, and we'll get more into that later. Now, another very basic concept of charge is that like charges, repel, opposites retract, opposites attract. Okay, so this is a very basic concept. You can see two oppositely charged particles, positive and negative, coming together, and you can see two negatives pushing each other apart or two positives pushing each other apart. These are very basic. It's a very basic concept, but in physics we will find later that we're going to be talking about forces again. We're going to be talking about forces and electric fields, and both these things are vectors, and we know from vectors that vectors have a direction. And so we're going to be looking at systems where there might be multiple positive or multiple negative, and we're going to need to develop the direction of these forces based off what their charges are. Okay, and so we're going to need to be very clear on what charges we have and what force is being happening there. Are they pushing each other away, or are they trying to pull each other together? Okay, so that is a fundamental characteristic of electric charges. This is fundamental. Okay, it's going to be a underlying basis for a lot of the problems we try to solve in this class. Okay? And another fundamental characteristic is the law of conservation of charge, or electric charge. Charge is conserved. Okay? Charge is conserved. And what that means is the net charge of a system is constant. So for example, if I have two metal spheres, and one is negative and one is slightly positive, and these two come in contact, the charge of the whole system is going to remain constant. Electrons might flow from one to the other. But we're not going to gain it from anywhere else. Okay, the net charge is going to be constant. No charge is created or destroyed. It is only transferred. Okay, just like conservation of mass. Okay, and our last thing for this video is the idea of conductors and insulators. Conductors these readily These readily conduct charge. Or in other words, electrons flow freely. And insulators are the exact opposite. Insulators do not conduct charge. Okay, or they have difficulty conducting charge, and so electrons do not flow very freely. Do not flow. Okay, and this picture up here, you can see here's a picture of heat and a picture of charge, and typically good heat conductors are also good electrical conductors. So in general, metals conduct heat very well. They also conduct charge very well. Okay. It's not going to be the same all the time, but it's going to be same most of the time. Okay. So, for example, a common insulator would be like rubber. Well, rubber also is a very, very good insulator for charge as well, for both heat and charge. So, like I said, these are just some basic concepts of charge. We have conductors and insulators. We will discuss these more in depth as we go through this unit. We talked about the conservation of charge. This idea of conservation is going to come up in our problems through our equations. Like charges repel and opposites attract. This is going to be a fundamental principle as we solve problems every single time. And the unit of charge here, because we are actually going to be calculating how much charge is transferred and stuff like that. So